My name is Greg Welty with the University at Buffalo, CIE 303 Fall 2013 class with Susan King. This is the extra credit assignment. Thank you. So for my extra credit video, I decided to talk about the space segment of the Global Positioning System, or better known as the GPS. There are three different segments for the GPS. There's the control segment, the user segment, and the space segment. Today I'll be talking about the space segment. So today I'd like to talk about the space segment. The GPS uses a constellation of 24 satellites that orbit the Earth at about 11,000 nautical miles, or once every 12 hours. The orbital position is constantly monitored and updated by the ground station. So on Earth we have thousands of ground stations, from handheld users to governments, and they're all over the world, everywhere, and they're transmitting into space to satellites. So there's 24 satellites surrounding the Earth, and I'm not going to draw them all, but these stations transmit to each of these satellites, or a minimum of 3 at a time. So each satellite is identified by number and broadcasts a unique signal. This signal travels at the speed of light, and each satellite has a very accurate clock. 3 times 10 to the minus 9 seconds is its accuracy range. Because the GPS receiver calculates its location by triangulation, the task of the receiver is to determine its distance from multiple satellites. So we want this ground receiver to find the distance to the satellite, and it needs 3 of these satellites, and I'll explain why later. So the GPS system uses 2 different types of signals to calculate the distance: code phase ranging and carrier phase ranging. So I have updated my drawing to show the receivers on the Earth and the satellites. So these receivers collect, decode, and process the satellite signals. So each of these satellites are sending a signal to the receiver, and transmitters on the Earth, which I'm going to call this one a transmitter, I'll put a T here, and this one a receiver, I'll put R there. So the transmitter transmits to the satellite, and the satellite transmits it back to a receiver. The basic receiver does not include a transmitter, but the receiver determines its location by triangulation. Now, I'm going to talk about triangulation in just a second, but right now I'd like to touch upon how these receivers do not know where they are in the Earth. This receiver could be anywhere. It doesn't know. It could be in the middle of the Earth, it could be in China, it could be in America, it could be in the ocean. But the fact is, it doesn't know where on the Earth it is. So we're going to determine this by triangulation, which I'll now discuss. So I'd like to talk about GPS triangulation now. So each of these satellites knows its distance relative to the center of the Earth. So this satellite S1 knows how far it is to the center of the Earth, which I'll mark right here. Each satellite constantly broadcasts its distance, where it can be picked up by this GPS receiver. But just knowing the distance from the satellite, one satellite, to the GPS receiver does not provide enough information. When the receiver knows its distance from only one satellite, its location could be anywhere on the Earth. It could be in China, it could be in America, it could be in the center of the Earth, or even the ocean. So until we have more satellites, the GPS does not know where it is on the Earth. Each of these satellites has a circle of influence, we'll call it, and it says that that GPS could be anywhere in that circle. So that basically is giving us an X, if we were to look at it on a coordinate system. So we have an X. Now if I were to say, let's use another satellite denoted as S2, that also has a second circle to add to the first satellite's circle of influence. So that provides us with a y right here. But we still don't have a z coordinate until we bring in the third satellite, which also transmits information, provides a circle, which gives us two different possible locations, and one of them is out in space and one of them is on the Earth. The two different possible locations is where the GPS could be. So the more satellites used, the greater the potential of accuracy for finding this GPS's location on the Earth. So in my example, I only used 3 satellites, but I could have used, say, these other 4. So I could have 7 satellites transmitting to that GPS, which will give it a better estimate of where its position is on Earth. So the factors influencing position accuracy is the number of satellites. So the more satellites you have, the more accurate your the GPS will find its location on the Earth, which is essential to many modern inventions like the car GPS, a phone's GPS. All of these use satellites. There are usually 24 satellites in the GPS cluster in space. Now, just because there's 24 satellites doesn't mean that your GPS unit will see 24 satellites. Usually it sees 3 to 4 because it basically looks at all the satellites on the horizon. So a satellite determines its position on the Earth by triangulation. The more satellites you have, the more accurately triangulation will be performed. That's it. Thanks for watching. My sources of information are www.gps.gov. Thank you.